first question on the 2018 AP Calculus BC free response is given by people enter in line for an escalator at a rate modeled by the function r. Here's what they give us. R of t equals 44 times t over 100 to the third power times 1 minus t over 300 to the seventh power for t on the interval from 0 to 300 seconds, and R of t equals 0 for t is greater than 300. The initial condition is 20 people in line at t equals 0, and people exit the line at a rate of 0.7 people per second.
Whoa, that's a lot of information. Let's break it down and do a visual representation to see what it all means. So, at the beginning, at time equals 0, there are 20 people in line for the escalator. The rate in and rate out are measured in people per second, so, after 1 second, 0.7 of the group of people will leave the line, and R of t, that large number you see right there, will enter. This happens every second. Hope that makes things more clear.
How many people entered the line for the escalator during the time interval 0 to 300? To find the total amount of something over an interval, you must integrate the rate. For instance, to find distance traveled, you integrate speed. In this problem, since we want to know how many people enter the line from t equals 0 to t equals 300, you must integrate the rate at which people enter the line, r of t, from 0 to 300. Using your calculator to solve the integral, we get the answer of 270 people. We think you'll get 1 point for the answer in units.
During the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? In order to find out how many people are in line at time 300, both the rate in and the rate out must be considered, as well as the initial number of people. The initial 20 people at time 0 must be added to the number of people entering minus the people exiting on the interval 0 to 300. In order to get people, the rates must be integrated to get rid of the per seconds. The rate in minus the rate out is integrated to give the integral 0 to 300 r of t minus 0.7 dt. Type this integral into your calculator and add 20 to get 80 people at time 300. In this part, we think you'd receive 3 points, 1 for the initial number of people, 1 for the integral, and 1 for the answer.
For time greater than 300, what is the first time t that there are no people in line at time 300? We then subtract the rate of people exiting, which is 0.7x, and then you don't need to add the rate in because at time greater than 300 it is 0. On the calculator, we then solve to find that x equals 114.286. 300 seconds then needs to be added because this is the time that we begin with for part C. 1 point is awarded for adding 300 seconds, in our opinion. 414.286 seconds is then the final answer for this problem. 1 point is awarded for answer with units. 2 points in total would be given for part C of this problem.
For part D, for 0 is less than or equal to t, which is less than or equal to 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. Justify your answer. To find the minimum number of people, you have to take the derivative of the amount of people. The amount of people is equal to the integral from 0 to t of r of t dt minus 0.7 t, the rate out, plus 20, the initial. Therefore, the derivative of the amount, a prime of t, is equal to r of t minus 0.7. To find a critical point, you have to set the derivative equal to 0. If you move the 0.7 over, then you have r of t equals 0.7. So, r of t equals 0.7. Graph both of these on the calculator and find their two intersections. The graphs intersect at both 33.013 and 166.574 seconds. Compare the amounts of both critical points and the endpoints. We already know at t equals 0 there are 20 people. For 33.013 and 166.574 seconds, calculate the amount. Do this in your calculator with the equation we already found for the amount. At time equals 300, there are 80 people. See Part B. By comparison, we can see the minimum people is approximately 4 people at time equals 33.013 seconds.
But if that doesn't work for you, don't worry, we have another way. To find the minimum number of people in line on the interval from 0 to 300, you can graph r of t minus 0.7, because that's the derivative of the amount. We can see where this crosses the x-axis. The two values we get from this graph are 33.013 and 166.574. These numbers are either max or min because they are critical points. So let's check the number line. This number line represents the derivative of the amount, or a prime of t. The numbers that should go on here are 0 and 300 because they're endpoints, and 33.013 and 166.574 because they're the critical points. Looking at the graph, we can see that a prime of t is negative from 0 to 33.013, positive from 33.013 to 166.574, and negative from 166.574 to 300. So there's a minimum at 33.013 seconds since it switches signs from negative to positive.
4 points, we assume that there would be 3 points awarded to Part D. The first point would be for recognizing that r of t equals 0.7. The second point for finding 33.013 and comparing endpoints. And the third point for finding 4 people and an explanation.